Hey everyone, welcome to the podcast. We're going to talk about a very interesting subject today, which will sound irrelevant, but we will make it relevant. This is sort of inspired by an essay that I'm working on about theories of everything, and I hope that what we talk about is useful in that regard. I think it'll be. It's about really the ultimate shape of the future when it comes to knowledge, as far as we live within the world set by Alan Turing um, and Turing computability. So I'm excited. I'm here with Josef and Igor, and we're going to talk about it. Shall we do introductions, gentlemen, as usual, or should we just proceed?
Let's just proceed.
All right. So I've laid out in this thing a set of ideas. Basically, there has been a long search for a theory of everything. Now, what does a theory of everything mean when we already know such things are impossible? How do we know such things are impossible? Well, if we believe Gödel, firstly, there is quantum space when it comes to computation, and that is computed that can be computed in Turing space, but there are things that are intractable in Turing space that are tractable in quantum space. So if we have a theory of everything, it has to be a quantum theory. Okay. So now if we take this view that we need to have a quantum theory of everything, the question becomes, how do we deal with Gödel, who established, when there's a broad consensus around it, that there is incompleteness and I think it's inconsistency and incompleteness, Josef, am I right? Or
You get either the one or the other. Yeah.
Yeah, you get at least one of the two. You can get both.
Yes.
You can get both. So I'll read the internet version. The incompleteness theorem states that any sufficiently powerful formal mathematical system is either inconsistent, which contains contradictions, or contains true statements that cannot be proven within itself. That's incomplete. It's either inconsistent or it's incomplete, revealing limits to provability or a gap between mathematical truth and formal proof. Now, when we talk about mathematics exists within Turing space, except if it's quantum mathematics, which we won't talk about. But mathematics exists within Turing space, as does computation, what our computers could do. Now, as far as we understand, the human brain is not a quantum system; it is rather a classical system, and classical systems are Turing systems. Turing systems have certain capabilities and certain limits, which are extensible to mathematics. That's not quantum. So essentially, we say, okay, let's look within the space of Turing things. How do we ground things? What is the ontological or metaphysical framework that we can use to ground things? Right. This is a topic in AI today about like ontologies and using those to define truths and a hierarchy of truth. The problem with all of these ideas and with ontologies as such is that you cannot really justify calculus from within itself. This is what Gödel sort of is. Even though calculus is complete and things like that, that's because its expressibility is not as high as a complete formal system that Gödel's talking about. So you cannot justify calculus from within itself. That's the point of Gödel. So you have to come up with a meta-calculus way of saying, like, what is calculus for? Like, what makes it useful, right? But then how do you justify that meta-calculus thing within mathematics, right? You're going to keep running into an infinite regress. And then you say, well, let's step outside of mathematics. Let's go to human language. Can we justify things there? We say, well, yeah, human languages are a more loose way of talking about things, but they're not really able to solve those problems. It's more that human mathematics, human language is more of an approximate mathematical game. But if you were to make it precise, you would run into the same problems. I am totally losing the thread here, gentlemen. Excuse me. So let me read some excerpts from the essay, which is very, very poorly written and will be rewritten. The search for theory of everything is a fool's errand. If it seeks a single absolute justification for existence in a universe, for like everything, the only universal truth is that things are contextual and contingent within those systems. Any system of meaning we construct, from pure mathematical to the felt reality of consciousness, is a self-contained framework that cannot be justified by any principle beyond its own starting conditions or axioms. Now, that's not totally true, but there can be relations between different formal systems, okay? But those formal systems are then within a metaformal system of relating them, and that metaformal system runs into the same problems. So while they're not arbitrary, you can take any two formal systems and almost always come up with a larger formal system that forms some relation that does not contain all the specifications of either, but has some relations between them. So they're not purely arbitrary. Even though you can do that, that meta framework system has the same problems. And now I'm sure I've lost everybody. um, but let me make it a little bit more concrete, okay? Mathematics is not discovering new things. Mathematics contains a set of axioms or initial conditions, and then the mathematics that we invent/discover is already prescribed at the beginning within the scope of what we've set out as possible, right? Every move you make in chess is already given this space defined by the rules. But there are still new chess moves happening because the space of possible chess moves is enormous. Uh, and if you look at a game like Go, that space of moves is far bigger than the number of atoms in the universe, etc. So while it is finite, and while it is predetermined by the rules, you can always come up with a move that has never been seen before by creating the right conditions off the board. Okay, so in practice, it is it's incomputable in practice just because of how big it is. So if we consider mathematics to be like that, which it is, largely speaking, and yes, you can make new chess boards and new Go boards, new systems of rules within mathematics or new kinds of mathematics, you're dealing with the same kind of thing. Take another example that's fairly simple, Lego, right? You can build an infinite number of things with Lego, especially if you can collect an infinite number of pieces. But all the shapes that you could possibly make are predetermined by the kinds of pieces you have, by their colors, by their sizes and shapes, etc. So everything is predetermined, but there is an infinite number of them that you can do. So what we're doing is we're not progressing in terms of, we're not discovering new things. We're just finding new sort of landscapes or vistas. And now the argument is that if we're Turing machines, we're just like these formal systems, because computers can compute everything we can, and computers are running on a mathematical binary system of ones and zeros. There is nothing so far that a human can compute that a computer cannot compute. Okay, it's just likely that human brains are better approximation algorithms than computers, which are not very good approximation algorithms. We've had billions of years to come up with some very sophisticated and very efficient and probably highly parallel approximation algorithms that give us directionality and approximate things to go. And that's something we could talk about in the future. But essentially, the human brain is, because it is a Turing machine to our best understanding, because Turing machines have the same problems as mathematics, the human brain is not inventing new things or discovering new things. They're not really, they're already within the bounds of what's possible. Okay. So now what has to happen is that instead of discovering new things, we're creating webs of meaning, or these interconnected networks of meaning. For example, we have the English language, which is a system of meaning. Now, it's similar to other languages, but not the same as. Now, the English language can be used to print things, right? So it's interacting with the physical world. It can be used to send emails. It can be used to declare war, right? It can be used to negotiate contracts and deals. All sorts of things are done within it. But it is not the same language as Mandarin, which is a significantly different language framework. And it is bounded and finite. And if we say arbitrarily what makes English true, or what is a universal theory of language between English and Mandarin, either we're going to lose some detail, which will cost us some expressibility, or we're going to create a much more complex meta-representational, which will not actually generalize, which will just add both specific cases. Or we will say there is some incommensurability between English and Mandarin. There is some degree of us not being able to perfectly map them at the level of complexity that they exist in, right? If we assume that they're efficiently encoded. So the argument is that not only are meta-ontologies that are beyond Turing impossible, so long as things at Turing, and also that the physical universe will interact more and more with Turing like networks of meaning, like human civilization, and that human civilization like the English language is of a similar kind. So human civilization is the most complex things that exist in the universe, right? It's more complex than individual humans, arguably. and it is much more complex than what's out there in the physical universe without assuming alien intelligences. So human civilization is the most complex thing, and that human civilization interacts with planet Earth, and over time, if it continues to flourish, it'll interact with our corner of the universe. Such civilizations, alien civilizations, will at some point interact with each other. Okay, that'll be the future, and they will all be operating within this Turing space. And there will be some partial commensurability. There will be partial incommensurability. Um, and that human knowledge will have the same. It will be the same way. That's why we have different disciplines. That's why the legal discipline is different from physics in terms of language and language games, because they have to be efficiently encoded, semi-self-contained, semi-self-coherent systems of meaning. And you cannot really get a meta-ontological framework beyond this. Now, can there be better theories of the physical universe? Of course. Can there be better discoveries about chemistry and all of these things? Of course. Because these are done by computational processes, yes, but so far we don't know the algorithms that are creating them. And sometimes they're highly complex when it comes to biology. Highly complex, to the point where they might not be a perfect algorithms. They might be algorithms that are so complex that we can only do approximate representations of them. So it doesn't mean we can't do more science. It doesn't mean all those things. But the claims are we will not have a universal theory of everything. Whatever theories we have will be within the bounds of Turing space. That whatever systems of meaning exist, there will be partial commensurability and partial incommensurability. Multiple disciplines will continue to exist no matter how smart our AIs get, which also, in good news, means the following. There will not be a singular godlike entity that kills all of us and takes over everything. There will likely be, even if that exists, that entity will be modular, or there will be sub-entities or different entities with different goals, different heuristics, different things, which are going to interop and interact with each other. So it leaves the space for a future of multiple intelligences and multiple systems of representation, etc., rather than a singular totalizing entity. So this is my very, very, very poorly articulated, very long, overly, tangential layout of where I'm going. But at some point, hopefully, this will come together, and we'll have something to it. Thank you for your attention.
Yeah.
That was
now when you try something.
Well, let's add one thing. I don't know whether I've ever mentioned that, but what I actually studied is I've studied physics. And my very, very, very first lecture of physics was in Technical University of Munich, physics department, Professor Franz von Feilich, standing up and saying, "Welcome to your first lecture in physics. Before we begin, let's clear up this one thing. Physics doesn't explain the world. Physics merely describes it. And these descriptions are actually quite patchy." So when I hear Sheikh talk, the first thing that came to the first thing that came to my mind was that part of the physics lecture, because we can, of course, from a semantic point of view, from a meaning point of view, we can try to establish one system of meaning and compare it to another system of meaning. Define a meta system that allows us to compare these two and relate them to each other. But what I've learned in that very first lecture of physics is actually from a system of meaning. The other direction is at least as interesting. How does the meaning that we give to things, that is something that humans do, we give meaning to the events around us, to the events in the physical world. How does the meaning that we give these things relate to the things that we experience, to the objects of experience? Because, for example, if I'm in my office, I'm not in nature, but otherwise I would pick up a stone and hold the stone into the camera and I'd say, we think this is a stone. But that bunch of atoms that I have in my hands doesn't know that it is a stone. None of the atoms knows that they have a different relationship to each other than, for example, to my hand or to the ground I've picked it up from. And so everything that we're talking about is well, that is ontology. We are putting meaning onto the experience that we have.
Yes.
And the direction to look at the relationship between the experience and the meaning, I find equally interesting to the direction of how does one piece of meaning relate to another piece of meaning.
I think that's a very interesting idea about like what meaning is and how to relate it. I would say my essay doesn't really touch on that, except to call it, we have symbolic representational systems, and we have what things mean are like how to interpret things, let's say, within that system. And that's I think that's a coherent concept. But I think what meaning is as such is a psychological it is a psychological and sociological and anthropological thing. But I think meaning is a computational device that the human brain uses in the world. And while it may be a useful computational device to look at, it is not. I think it is still a computational device.
I can add from my perspective. I studied languages, and you mentioned in the theoretical part, let's call it that way, that any system is basically self-referential. And when we're speaking about the way we describe the system, it is even more self-referential because you're using the language. And apart from the fact that speaking different languages, explaining and describing the same things, you get into a problem of understanding and the problem of different meaning of words and different relations which they are into. It's also the problem that even on personal level between various people have different experience, and they may have different understanding of the same concept. That's why communication with people is very self-referential and very complicated. That's why we get into troubles with it all the time. A good example, which a very simple example, I would say, a very simple example example of that I can give is also, for example, is the fact that when we're trying to speak about, let's say, objective truth, but the value that we set to certain categories in the language are not the same, and trying to discuss the same objective truth using the same, or if it's worse, different languages, we get into trouble again explaining things a little differently and delivering a little bit different meaning. A very simple example: when I say that I went to the shop and the shop assistant gave me something, in English that sounds that I, as a person, like I went to the shop and the shop assistant, being a neutral personality, gave me something. But when I'm saying it in Ukrainian, the shop assistant must have a gender. And I cannot enunciate this sentence without specifying the gender of a shop assistant, because the verb that says provided in Ukrainian language is encoded with the category of gender, and there's nothing you can do about it. And those two, if you compare let's say, the amount of meaning that those two sentences have, now in English and in Ukrainian, they have very different amount of meaning. And since we pursue that meaning through our value structure, through our value system, the perception of the same sentence in various languages will already be very different, and this is why we have problems in human communication. And even when we're trying to explain the physical phenomena, we actually get into the same problems. So that's where we are.
I want to say something I think that's be quite useful. So here's I guess the claim I would be making is, look, languages are bounded by Turing space. Okay, I think that's fairly uncontroversial. Okay, but languages are I would say, instead of calling them systems of truth, they're systems of representation. Okay, so for example, I went to the shop and bought a piece of bread. Okay, I went to the shop. I went to the shop. It was a big shop, and I bought a piece of bread. Okay. I went to the shop, and it was a big shop, and I bought a piece of bread, and it was this brand, and I paid this much for it. All of those are true arguably they're all true. Like just to speak roughly in everyday language, that's all true. But I've given you different levels of expressiveness in the representation, right?
Mhm.
I can also represent the same thing differently, right? I could say that movie was very good, or I could say that movie was really boring, right? And two people watching the same film may say those two different things, right? Now, if we talk about truth, already it becomes difficult, right? But if we talk about representation, they might actually both be saying the same thing. The guy who thought it was good might have thought that the aesthetics were really good, and this was really good, and that was really good, but the pacing was slow, right? But he actually prefers a slower film, whatever. The guy who said it was boring, watches a lot of action movies, and for him, this was like a very boring movie. So they're both so if we look at representations, you've heard of the metaphor of like the elephant, right? Like in the blind man and the elephant, like they're each grasping a piece of it. You think of language as describing some of that elephant, then we're all describing parts of it. Now we're all inaccurate as well. So there's like, we're not only incomplete, but we're also inaccurate, and that has to be the case per Gödel. It has to be the case that way. But suppose we were all accurate, then the more dimensions you have, the more complete representation you get of that elephant. Can you guys still hear me?
Yes.
Okay. I think Josef is. I'll pause for a moment. Josef, can you hear us? We can hear him, but I think he's lost us. Josef, do you want to turn it on and turn it off and turn it on again?
Probably should just wait for Josef.
Yeah. Hey, can you hear us?
Can you hear us now?
Now I can.
Okay, great.
Sorry for that.
Great. No problem. We'll just cut it out. So as I was saying, yeah, if you look at it as the parts of an elephant, right?
Mm-hmm.
And we're all like different perspectives are adding dimensionality to it in representational space. More perspectives can give a more complete representation of a thing, right? So it can be richer. But those representations have to have, again, more fundamental alignment, right? Like human representation works because our eyes are all the same and our ears are all the same and we walk the same. Like we have a lot of similarity in our hardware and software, so that our descriptions are fairly we can transferable between people, and we can apply that description to our software hardware system. That's like, we're kind of these analog computers, but because we're all fairly similar, we can talk to each other essentially. Computers are much more perfect systems like that, and so their commensurability is a lot higher. Now that has other trade-offs and things like that, but that's why Jeffrey Hinton thinks that computers do a better kind of computation than we can as analog computers, which is fascinating. But yeah, I think language is not a truth game. I think it's a representational game, and I think to understand somebody is to understand their representation. And that's why, even though in language we're not saying anything that's like interesting from a Turing perspective, representation is very, very important. And like when you're climbing up a mountain, like, yeah, I'm climbing up a mountain, there's nothing that interesting. You move your legs and you go up it. But unfortunately, as it happens in physical reality, there's a lot of nuance to how you're going to climb the mountain to avoid various dangers. And so if somebody's been up Everest a bunch of times, you would want to listen to this person and also have a guide, et cetera, et cetera. So language is, I think, a representational game. And again, that requires an incommensurability as a consequence, because each representational game will have some distinctions from other representational games. And we will not, because meaning is created within these networks of activity, of doing stuff, like of where purpose and meaning are like goal oriented some things, let's say. Because of that, we will always have these incommensurability, like patchy webs of activity, meaning representation.
Actually, if you go a step back and pick up old German philosopher Kant, as far as I understand, he's taking what you just said in a way to the next level, because what he says is truth, at least I've been told, I haven't read it myself, truth is a characteristic of a statement, a quality of a statement. Now, there is apparently an entire library of philosophy behind what a quality is, but then never mind. The interesting question is, what is a statement? and I've been told a statement relates mind to matter. So now we're back in my physics department. We're describing the world. We're making representations about things, and because mind and matter exist on different logical levels, what you just said, Sheikh, is actually manifest. You will never have a perfect representation because the representation is different from the thing that is being represented. It's kind of a map and territory difference, map and territory
so
gap.
That's 100% always true.
And
but
from
the
there,
question is, which is the thing I'm doing is flipping the map and the territory.
Yeah.
That's the interesting part.
There is something else that you're doing. Map territory gap, which means that truth is never 100%, unlike what we learn in mathematics. Truth is never 100%, but truth is always, like in the example that you gave earlier, when you said, I went to the shop and bought a piece of bread. It is true. But I went to a large shop and I bought that brand of bread and I paid that much for it in a way that is even more true because it provides more detail. It doesn't make sense to say one thing is true and the other one is not. It starts to make sense to say there is a continuity of more true than or less true than.
Yeah,
and the really fun part is,
go ahead.
When you look in, how does it work that mathematics has black and white truth, and describing the world has a continuity of truth, a fuzzy logic meaning of truth? You discover that when we're describing the real world, we are relating mental concepts to matter concepts, physical concepts. But when we're talking about mathematics, we talk about mental concepts in a relationship to other mental concepts. And suddenly it is possible to talk about things being true or things not being true. There is the truth of things that relate mental concepts to each other is a very different kind of truth from the one that we use to relate mental concepts to the real world. And that is, I find that really fundamental, and haven't begun to understand the implications of that.
So those are great points. Sorry for jumping in like 3 times while you're talking. So first thing that I'm doing is flipping what I consider is the map and the territory. Okay. Mm-hmm. So traditionally, it's considered the world is a territory and the mind is the map. I'm saying it's the other way around. I'm saying the mind is the territory and the world is a map that the world is subordinate to the mind. Okay. In what we should be. So while these systems of meaning that we're talking about broadly as language, okay, language is not nearly as complicated as the world is. That's true. But when we talk about neural networks, my claim is that, and if our brains are somewhat neural networky, my claim is that they will have richer, more complex representations than the world. Now, we already know that's true because, like, we can play chess and we can play Go and things like that and make good moves, right? So anyway, so I'm saying that the physical world is not represented as richly as we are in our, and that means that the territory is us and the map is the world, and the territory will increase, and the territory of the physical world is just as meaningless as the territory of ourselves. Okay, but the acting force will be us and civilization and such on the world, and that's what will create meaning and truth because it doesn't exist in the world. It'll be contained within these systems. Okay. So now when we talk about language and we talk about this continuity of truth, I disagree precisely with that idea of truth. Because while you could say that representation is richer, yes, there are an infinite number of ways in which you could enrich that representation. Okay. So that's called the frame problem in classical AI and things like that. And the frame problem is unsolvable. Okay, the only way you can solve it is you say, well, I have a system, I have an agent with certain goals. Things that are useful as a frame are things that happen towards that goal. But how do we determine what frames are useful to the goal? We need prior experience. Okay. So over time, we have these embedded heuristics that arise. So it's not so if I say I took a car to the park and I took a car to the driving to the parking lot and parked it, okay, versus I took this brand of car and did this, those different representations, one can be more detailed than the other. I think that's indisputable. But whether one is more useful depends on how much time I have to communicate that information. And I don't think I think while the representation can be more detailed in one way, there's always a trade-off in reality. There's always a trade-off. Because there's always a trade-off, I think using a value judgment statement like truth is not appropriate. I think we can talk about detail of representation, but as we already know, detail is not always desirable. Now, there can be truth that's important, and I would say that comes in when there are certain descriptors that, there's truth of omission, right? So you might give a description that's concise and it's true at that level, but if you were to add a bit more detail, it would actually change what the meaning of it is, right?
Mm-hmm.
So,
like in Igor's example.
So I drove across the street. Okay. Where it says I drove across the street, an old lady was walking on it, and I drove over her. Right. So it's not that detail changes what happened to some degree, right? And I drove over the old lady, and then the police came, and now I'm in prison. Right. That's a little different, right? So that I think that's crucial, but I don't think detail that doesn't change things is more true in some sense,
Yeah, I would add to that. The concept of more and less true is also pretty much predicated on the system of values. And the representation is very much predicated on the comprehension of the receiving side as well. That's why, Josef, you made a point that computers are much more efficient, and that because they have the same value system. That's why they're very easy to share information between each other. They essentially use the same value system. We as humans don't use the same value system even within the same society, and not even speaking about different societies. Very simple examples which I was given when we were studying is, for example, if you're speaking about snow and you use the word snow, and then you're talking about snow to a person from, like, for example, Eskimos ethnic group, they have 27 ways of calling the snow, and those ways exist, and those words exist because they are important for them. And we just have one snow, sometimes two, but the second one is bad, and that's the only way. Like differentiate, like for us, differentiating snow by color is enough. For them, it's not, and that's the problem of comprehension. And you can say that there is more truth in their understanding of snow than ours because they have more ways to represent it. And it seems like let's say in terms of volume of information, their term of snow snow represents more information about this specific physical phenomena than our word for snow, because their words are more specific for that. But again, it stumbles upon the comprehension, because, for example, if you are trying to deliver the truth to a person who does not understand that, then they will not even understand what you're talking about. And a very simple example would be not even the different types of snow, which is, I don't know different types of snow. They do. But for example, if I'm saying that a car parked near my house, that's a random car. If I say that Toyota Highlander parked near my house, that's a much more precise description. But if the person doesn't know what is Toyota Highlander, and I say just that a Toyota Highlander parked near my house, they don't even know that it's a car. Mm-hmm. Something like that.
Mm-hmm. Yeah, I mean, what I was trying to say is not that there is a universal and objective scale of what is more true than the other thing. The only thing I was trying to point at is when we relate mental concepts to physical concepts, then we are out of the world where we can talk about things that are true and false 100%. It's no longer black and white, but we suddenly get shades of gray. And then, of course, like in both your examples, you will discover necessarily that it depends on the people talking, on the sender, the recipient of the message, whether to which extent they are using the same or similar codes, basically grounding what they are saying in similar experience. If I don't know a Toyota Highlander, then I can't ground the words in experience. And it also makes sense to think about it from the point of view of a goal. When you want to, when I like the bread that you gave me for dinner shake, then I want to know the brand of the bread. But if I don't care about it or I didn't like it, then the brand actually doesn't matter. So,
yeah, you might want to know the brand so you don't buy it again. But yes, yeah.
I again can't hear you.
Oh, you can't hear me?
What is going on there? Sorry, I'll be right back.
We'll add one interesting point. By the way, Sheikh, we were discussing it with you for about half a year ago about the complexity of mathematical problems.
Yeah.
It's very specific to this language problem, very characteristic to this language problem.
Can you hear us, Josef?
Yeah. Different headsets, now it works.
Okay, great.
Sorry.
Yeah, you look very much like a captain, in command. It's good. I wanted to say something to respond to that. So I think the thing I've done is said that both physical reality and mental reality exist within Turing space. Okay, that's claim one. Claim two. So that's they're both within Turing space. So they are. There is a way to translate between them. Okay. Second thing I've said is that the mental space is superordinate to the physical one because it has much more expressiveness, virtual representative capability, and it's agentic. It's potentially agentic. It can do stuff, right? So I'm saying that we will understand physical reality, but the essence of what the universe is will not be answered there. The essence of it will be created by these systems of self-contained meaning, things like human civilization. And these systems will grow and complexify and stuff, and they will interact with other systems, hypothetically alien civilizations. And what it'll be for one system to win is that it's able to beat the other system or it's able to cooperate. I don't know what those relationships between those systems will be. But that what we see in human society today, i.e. we have different fields of knowledge and we have different people and different that I'm extending that forever into the future as the way it will be,
Yeah.
Human
society has been like that since forever, literally. Like we are same personalities like we were 5,000 years ago. Like our technology is improved, but our psychology doesn't seem to improve. And so the way we establish relationship between each other is pretty much the same.
Yeah.
So it will always be like that. That's why I think there are limitations to what the human as a society can achieve. And there are limitations to the level of problems that we can solve simply because of simply because of human nature.
Yeah. So I 100% agree with this. I'm generalizing it to other kinds of like genetic engineering of humans and to artificial life. Like I'm generalizing it to all forms of minds, not just human minds.
Okay.
But please continue.
Yeah, I wanted to add just like a thought out of blue sky. I've been like running around with this idea, and I wanted to express it like regarding the mathematical description of basically physics and mathematical description of the physical reality. We are often trying to show it. We're trying to kind of I don't know how to use the word, pretend that physics or mathematics explains reality in a more or less objective matter. And often mathematicians say that mathematics is like the only objective language. But what you said, Josef, at the beginning contradicts to that, absolutely. And I agree with that. And the thing to consider is that even the fact that we are using decimal system as mathematics is predicated by the fact that we have 10 fingers. and there's no other reason for that. There's no reason in physical reality to use specifically decimal system, and the complexity of problems that we're facing is predicated on the fact that we use this specific mathematical language using decimal system to describe them, and that's why some mathematical or physical problems are for us extremely difficult to calculate, simply because we're using the language, the decimal system, which does not make them easy to solve. If we would use some kind of other language to describe them, maybe they wouldn't be such big problems, and maybe lots of mathematical and physical problems that we had could be solved easier if we simply used a different language to describe them, which is again, we go back to the problem of representation of representation of meaning. It's all we're trying to describe physical reality with a human language predicated on our psyche, essentially. And our psyche is not perfect, and our language is by far not perfect. Something like that.
Sounds a bit like Galilei when he said, "It's not the Earth that is the center of the universe; it's the sun." Actually, from a physicist's point of view, you can do the entire planetary mechanics from a geocentric worldview. That works. You can also do the entire planetary mechanics from the point of view of a heliocentric worldview, and suddenly everything becomes a whole lot simpler. It's not like the Earth is the center of the universe or the sun is the center of the universe. It is what is the coordinate system, literally, that I am choosing so that I don't break my fingers when I'm doing the calculations.
Yeah. That's exactly what I'm talking about.
Coordinate system as a special case of a language that you choose to frame and solve a problem. And the fun part is when you look at, we've been talking about a lot of fun things here. My central statement has been, there is something like mind and there is something like matter, but actually we didn't even investigate what that is. When I asked my philosophy teacher what is mind, his reply was, "I'm sorry, I wasn't allowed to work on that. It was communist German Republic, so my mind doesn't exist in that worldview." But when it comes to matter, he was actually he could tell me a lot, and he said there are actually 3 different independent views among philosophers what matter is. The first one is matter is objective and independent of the observer. And if you want to do physics, you need to take that worldview, because otherwise it just doesn't work. That is why quantum mechanics is so weird for a physicist, because suddenly the observer plays a role that doesn't contradict physics. It contradicts the worldview underlying physics. The second worldview that you can have is there is an objective pre-existing being that is defining matter, popularly known as God. That is a worldview that I simply don't like. And the third version is coming pretty close to what Sheikh has been telling us. There is no objective world or matter outside of us, but it's actually somehow a huge consensus that we are creating all together, even though we don't know how we're doing it. So mind is, as you called it, mind is agentic. By thinking about things, by describing things, by representing things in a certain way, we are changing things.
So I love this, okay? This is why you stopped looking at philosophy. I disagree with all 3 of those descriptions. My description is, I think, simpler and I think clearer. My description is simple. It is that there is a world that's independent of us, that interacts with us, but it is not fundamentally defined by us. I also think there are minds that are not fundamentally defined by matter. Yes, there's some relationship, and yes, mind is composed of matter, but that doesn't mean that. Okay, there are these 2 things: mind and matter. Sure, I'm with you so far. What I'm saying is that matter exists within Turing space, and I'm saying mind also exists within Turing space. Okay, so matter is a kind of computer in Turing space. Okay, matter is a thing that does that interacts and operates by doing computations. It's not. It doesn't have to run circuits to do the computation. It just runs physical laws.
Mm-hmm.
But I'm claiming those are computations, And I'm saying that mind is much richer and much more expressive, and therefore superordinate to matter, and they're both in Turing space. And that we don't really have to particularly try to squeeze meaning out of matter, it doesn't exist there, or try to subordinate ourselves to matter in some way, that mind will and is and has been superordinate to matter, and will increasingly shape matter to the ability where we have the capabilities to influence the computation. Remember, matter is a physical computer. Like, it is actually doing like when two planets are doing a computation of what will it be like to collide with each other, they are colliding with each other. They're actually doing that. Okay, so if we're to influence matter, we have to have the ability to interact with that physical computer and make physical interventions. And our ability to control matter influences is determined by our ability to control that physical computer at that level. By dreaming up new philosophies, we don't change what happens there, right? So I'm kind of like I think I have a different position on all three of those, and I think it is a clearer and simpler position than, you know, I think philosophy is a profession of obfuscation, you know, and lifelong obfuscation. Solving problems is not interesting, right? Having them is interesting. So
yeah, but by the way, you can make a very simple comparison here. Like when we're like parable, maybe it's a parable, maybe it's not. I don't know. When we're speaking about distinguishing mind from matter, we must understand that we're using a language reference system which gives a certain meaning to the word mind and to the word matter. And our understanding of those concepts is like 100% predicated on that language system. And even the existence of those words exist in that language system, and our frame of mind, again, mind, is set in a certain manner because we use that referential system. That's it. And if you are considering like matter as a physical computer that does the computation, and mind is like a set of principles which define those computation, then for the practical, for the practical approach of doing the exact computation, they are technically all the same thing. Because the exact process of collapse defines how this collapse is going to work out, and the representation of the result of this collapse in real world shows the, like, basically you see the result in the real world, and then you describe those results based on the laws of physics, right? The laws of physics do not define reality; they just try to describe it with a certain level of success. And in this regard, mind and matter is totally the same thing. And again, we can make a very amateurish on my behalf comparison that if you look at an atomic level, there is no difference between matter and energy to the same extent as there is no difference between mind and matter in this extent. Like, if you go to the actual representation as deep as you can get, or at least as deep as you can get in the reference system that you can, it may turn out that certain phenomena are simply, like, again, like mind and matter. We use those two terms for convenience, but for practical purposes, they may represent absolutely the same thing, especially if we change our reference system or we just use a little bit different reference system. And that may simplify, like we speak about the problem of Galileo, that may simplify our computation, because now, instead of trying to solve the problem of relation of mind and matter, we simply describe how this, like, again, it's a very oversimplification. We simply describe how the result of interaction of matter works out, and that's what we get, essentially. And on the practical level, there's no difference.
Yeah, I like what you're saying, Igor. So I'll rephrase what I've said. I think matter is stupid mind. Okay. and physics studies it, and there are certain laws it has. For example, entropy, right? A very, very big thing. And sure, there's entropy, and entropy is always increasing. Fine, but that's only in that really dumb system, right? So if we stop trying to reverse entropy, which hopefully it's possible, but so far we don't have a means. If we stop trying to reverse entropy and say, look, this physical system is dumb, but we can build much more intelligent systems that can do far more computations. And so we're not reversing entropy in terms of what the physical computer understands, but we sure are able to do get far more bang for our buck out of one piece of silicon that we grant, and the computations that like we can absolutely reverse entropy when it comes to like systems of information processing and information representation. We cannot reverse entropy when it comes to actual like energy equations of like but if you talk about like, hey, like can we actually do constructive things that are more complex and do them very efficiently and create more and more complexity and more expressiveness and more possibility? Absolutely, we can. So again, I might have said it wrong, and physicists will feel annoyed with me. But essentially, the point is, I think if we stop trying to find meaning in the physical universe, we stop trying to reverse entropy and things like that. We should try to do that, but it may or may not be possible. Or we focus our efforts on constructing, because even infinity has meaning. It's all mental, right? And infinities can like are theoretically infinite, but in actual thing they're finite. We can create much vaster and much larger landscapes of possibility of experience. We can extend time by speeding up the rate of our own computation, right? Because like how many units of processing can you do per unit of time? Like that extends how much use you can derive from time. Again, the physical computer may work a certain way, but that doesn't mean that we're limited by that. We're not. And I think if we take this view, we get a very constructive and positive project, right, towards building computational systems, towards building representational systems, towards having really big ambitions in those directions. Whether or not we can reverse entropy and find wormholes or whatever,
So you're more or less arguing we should try to construct a matrix where we can live in?
I would say that yes, but the matrix would not be a self-contained entity. It would interact with the world, right? Yes, I would argue for that. But the matrix, look, this is the thing, as Igor said, we're embedded in a language game where the matrix means something negative already. So I'm not advocating for something negative. I'm advocating for a continuation. Look, I'm not talking about the matrix as much as art. Okay, we enjoy art, we enjoy music, right? We enjoy cinema, we enjoy sports, right? We enjoy competitive games. Many of us even enjoy work, right? These are all games of kinds of representation, of various complexity, et cetera, et cetera. I'm saying these are the games that are actually meaningful, even though within a Turing system they're bounded, as we've described. And these are the games that we should extend to indefinite horizons. I'm not saying necessarily we need to do visual art. Art can mean something different in the future. Work can mean something different. We may not even use these words at all. We may use totally different. It may be something totally different. But I'm saying that is directionally far superior to attempts to find or try to say, well, this is a physical universe. Even if it's around for another 10 billion years or 100 billion years, what does it matter? It's going to end someday. So what's the point of doing anything now? Right?
I will interrupt you, sorry. Like what you're saying is the most positivistic and romantic conclusions that we could come to, actually. Because what you're saying, if to say in simple words, is let's just continue the journey because it's fun. Essentially, and that's a good and it goes back to the idea that's it's the idea of the path and not the final goal, and that the path has value. And why the path has value? Because humans are walking the path and not just going towards a final goal, and which is predicating on our psyche as intelligent monkeys, because we need to entertain ourselves with something good enough to continue our existence and make it less gruesome and more fun. Essentially, if to say in the most simple words what you're saying. That's why continuing scientific research and moving towards an unreachable goal of achieving, I don't know, level 4 civilization, whatever, is kind of a good thing of itself, even if we never reach it, because it's fun. That's it.
And if my philosophical position is true, and I use that word very consciously, then it is also democratic, which is very interesting. right? It is also democratic, which I love, right? That was not, I had no object to its being democratic when I started.
I know what to add
Yeah.
here. Tell me when you.
And also the other thing I want to say, Igor, I want to spice up your version a little bit. It's also a race for survival, okay? There will be alien civilizations, hypothetically, that could come and destroy us and take our resources because they're playing a different game than we are, right? And we don't know this stuff. So the point is that we should also anticipate that even though they're vacuous in the ultimate sense, because mind is superordinate to matter and because we're living in matter and we're minds in matter, we can be destroyed by other civilizations that have better systems of representation or this thing. So even things like we should continue to innovate also for survival and things like that.
Yes.
And
Yes.
to value what future
Yes.
lives could do with what we make possible for them today. It's not a
I've
pure
seen-
romantic project.
Yeah. I've seen a good example here, which will lead to a bigger argument. Statement, not argument. I've seen some kind of, I don't know, Discovery Channel program 20 years ago when I was still in high school, and they were saying that they tracked some kind of Arctic fox and how much it moved. And they figured out that in a matter of months, that Arctic fox actually moved for more than 4,000 kilometers. It was just roaming around and without any specific purpose. And they made a conclusion that for lots of animals, constant movement is the way of survival, because this is how they find new resources and new places to live and other animals to multiply. Because and there is no like specific goal which they're going. They're just using this path as a modus operandi. This is how they live. And for humans, it's basically the same thing, because if we're speaking about our life, let's say our planet, as a finite system with a finite amount of meaning, there is a finite amount of solutions. And if there is a finite amount of solutions and we have problems to which we haven't yet found the solutions, there is a chance that there is no solutions to this problem, which makes us very fatalistic. But if we're speaking about path as a fun way to live, as a value, and we understand that our system is not perfect, but just keeping going is good enough, then we take we understand that our solution may not be now. We may not have the knowledge to solve it, but maybe sometimes in the future, following this path, we may find a solution. Which, by the way, this is personally my romanticized way of romanticized worldview, which I personally think that a very important thing for people to solve lots of social, political, military, so on and so forth problems on Earth is to go into space. Because Earth is finite. We're stuck on this sphere, which has a certain amount of square kilometers, and we are not really getting along very well with each other in most cases. But if we have a way to escape, that's a way to escape. That's continuing the path. You don't have the solution for the problem here. You can go to another place. And space, though it's technically not infinite, but in practice, it's so big that we'll never reach all its parts anyways. For us, it's practically infinite, and that's which gives us an infinite amount of ways to solve the problem. So that's why if you you are stuck with the problem, you just keep going. That's exactly what I wanted to say. That's why I'm very, very optimistic and very looking forward when we'll start making bases on other planets. And we'll have the Emperor of Mars. I even know the name.
I think I really like that idea that you just put forward, that life is about keeping moving. It's not about arriving. It's about moving. And the other thing is, one of the frontiers of knowledge things that I've poked around is we may or may not want to go to space. Our planet is finite. You're absolutely right. But if you look into the oceans, you discover that there is such an unbelievably vast part of that finite planet that we live on, where we know more or less nothing about, that there is still another infinite set of possible solutions to be discovered out of the Lego pieces, as Sheikh has mentioned earlier, or the chess moves that are at our disposition, that we haven't even seriously started to tap into. I agree with you. I'm a big fan of space travel. I've just wrote into the chat what Sheikh said about it's about what are we enabling for our successors is the epilogue of the novel the Uplift War by David Brin. That is what it deals with. So I'm a big fan of space travel, but the more I think about what is happening in the oceans, the more I realize even if we don't manage to go into space, there is still so much more to explore by just looking at the oceans, that we're definitely not running out of options to discover new possible solutions. Not anywhere near.
I can make a big argument on that from political perspective, but I will not. That's like a
Yeah.
discussion.
We should avoid specific political. We can talk abstractly about political systems, but to avoid real world examples.
I don't think we should avoid anything. We can inflict lots of hate in people. That's fine.
I would prefer to see it to create hope.
Yes, and I would really prefer this to be apolitical from specifics. I don't want to vein on current issues and give my spiel. There's no point. Everybody's doing it anyway. So, yeah. Well, thank you, everyone. I think this was a very, very good discussion on a variety of subjects, but I think the upshot for Igor, I think there's some audio coming from Igor. Okay, let's just mute. I don't know where it's coming from. Okay. So I think the upshot for all of you who are in the technology or AI or any of these spaces is that while things will change in the future, I do not expect there to be one super intelligence that takes over the whole world. It is possible. We don't know. I also do not expect that anything will fundamentally change about the kinds of diverse activities and knowledge systems that we have today. I think they will get more complex and more distinct and perhaps more diverse, but I think we will continue to have them. And that meaning is to be found within these systems and within what we have on Earth, and improving that and elaborating on it. But I don't think meaning will come from some Neverland thing, or from understanding the physical world better. Even if you had a grand unified theory of physical computation about the universe, which I think may or may not be possible, I still think that we will run into. I don't think that'll be the solution that gives us what we want in our lives. So, Josef and Igor, thank you for joining. Any final words?
Thank you. It was a really interesting discussion. Very, very interesting, as always.
As always. Thank you, everyone.
Yeah, thank you.